Assalamu alaikum. Welcome to my channel. M.Asif Math Corner. Today, inshallah, we will study about the kernel of phi is a normal subgroup if phi is a mapping from G to H is homomorphism. Homomorphism means operator preserve mapping in group theory. We have a theorem. Let G and H are two groups. Then the mapping phi from G to H is homomorphism. Then the kernel of phi means the mapping which is on the identity element is normal subgroup. The kernel of phi, you can see that, for example, we have a function y is equal to x square, and this is our x and this is y. When we give our value 1 to this function y is equal to x square, then 1 square of 1 is equal to 1, and when we give the value minus 1 to x, and minus 1 square is also equal to 1, it means that this minus 1 is also mapped on 1 and this one is also mapped on 1. So 1 is identity element. It means that this is the kernel of phi. This one is kernel of phi. All the mapping which is on identity element are called kernel of phi. So let's start. Let A and comma B belongs to kernel of phi. Here so phi of A will be identity of H, as I told that all the mapping in kernel are identity or map on identity element. So phi of A will be equal to identity of H and phi of B will be equal to identity of H. To prove that kernel of phi is a subgroup, first we prove that it is a subgroup, then we prove that it is a normal subgroup. So to prove that kernel of phi is a subgroup, we show that A B inverse belongs to kernel of phi, which is the requirement of subgroup. So apply phi on A B inverse. We have, as we know that the mapping is homomorphism. So direct we can see write phi of A B inverse will be equal to phi of A and phi of B inverse, or you can write phi of A into phi of B whole inverse. You can write as phi of A is equal to identity of element and phi of B is also identity element. So identity element into identity inverse, we know that identity element is a self inverse. So identity element, when we multiply identity with identity inverse, it gives us again identity element, because when we multiply 1 by 1 over 1, 1 over 1 is the inverse of 1, so it gives us the same result 1. Hence proved that it is a subgroup. Kernel of phi is a subgroup because A B inverse belongs to kernel of phi. Now we will prove that kernel of phi is a normal subgroup. Now we have to show that kernel of phi is a normal subgroup. For the normal subgroup, we know that this condition must hold, that G is from G and G inverse from G and K is from kernel of phi. If this belongs to kernel of phi, then it will be the normal subgroup. So G belongs to G, we apply the mapping homomorphism. Phi of G inverse K G, apply phi on, because it is a homomorphism, we can apply phi on other separately. Phi of G inverse, phi of K and phi of G. So phi of G inverse, because G is from G, and phi of K will be equal to identity element because K belongs to kernel of phi. So phi into G inverse and K become the identity element, and phi of G, because it is homomorphism, we can write it like this: phi of G into G inverse, and G into G inverse become also identity because G inverse is the inverse of G. So when two elements, those are inverse of each other, combine, we get identity element. So phi of identity, it's mean that this phi of identity belongs to kernel of phi. Hence proved that G inverse K G belongs to kernel of phi. Hence, thus kernel of phi is a normal subgroup. Hence proved. I hope you understood. Thank you so much.